Hello everyone. Some time ago I decided to buy myself digital tongs, but then I began to doubt how useful they would be. And so, after a while, when I got these modern digital clamp meter from GVDA, there is no doubt anymore. This is really a very useful tool. In addition, this multimeter has some useful features that many conventional multimeters do not have. In this video, I will tell you in detail about all the possibilities of these digital ticks, as well as test all the modes of their operation. In the description below this video I will leave a link to these digital ticks. If you wish, you will be able to get acquainted with them in more detail and, maybe even want to buy yourself such a useful device. Well, now let's take a closer look at these digital ticks. The packaging of this multimeter is quite large. 3 models of digital clamp meter are shown on the side. In my case, this is such a model, GD166B. This is also noted on this sticker on the box. The characteristics of the device are indicated on the back of the box. What are these digital clamp meter capable of? Measurement of DC and AC voltage up to 600 volts. Direct and alternating current up to 600 amperes. Resistance up to 60 megohms. Capacity up to 60 millifarads. Frequency up to 10 megahertz. The temperature is up to 1000 degrees Celsius. This multimeter also checks the diodes. Can detect electric field and find phase wire. In addition, there are functions such as the maximum and minimum measurement values, a flashlight, audio off, stopping the readings on the screen and measuring the inrush current. With such characteristics, this multimeter certainly deserves attention. Inside the box is a case containing a multimeter. The case is durable and comfortable, which protects the multimeter from damage, and this, of course, is a huge plus. Included with the multimeter is a thermocouple for measuring temperature. Comfortable probes with soft silicone wire. The maximum measurement limit for these probes, as indicated on their housing, is up to 600 volts and up to 10 amperes. Instructions in English are also included. And here is the multimeter itself, that is, digital clamp meter. Nice appearance. It fits comfortably in your hand. There is a film pasted on the screen, which I will now remove. If we compare these digital clamp meter with another GVDA multimeter, and this is the GD120B model, then the digital clamp meter are more compact. In height they are about the same, but in width they are almost 2 centimeters smaller. Thanks to this, it will be more convenient to use them, for example, when working in an electrical panel or when repairing a car. But, in fairness, it is worth noting that this GD120B model has proven itself perfectly. I have been using this multimeter for a long time and there have been no problems with it. By the way, I also reviewed it on my channel and, if desired, you can watch it. The link to this review will be in the description below this video. The multimeter comes without batteries, so now is the time to install them. Digital clamp meter are already making certain sounds. After installing the batteries, the multimeter turned on automatically. Here on the screen we see a scale with possible operating modes, as well as the ambient temperature, 22.9 degrees. At the moment, the automatic operating mode is selected here. Now I'll connect the probes. Now I will test all the modes of operation of this multimeter. The modes are switched with this green function button. The first mode is the measurement of the current strength. First, I will measure what current this color music car console consumes. In one of the previous videos, I restored this console, which was not working at that time, and if desired, you can also watch this video. I will leave a link to it in the description. To measure the current strength, one wire is needed. The readings are approximately 120 milliamps. Now, using a conventional multimeter, I will more accurately check what current this color music console consumes. It is well known that digital clamp meter are less accurate in measuring current strength. Approximately 124 milliamps. There is a slight discrepancy with the readings of digital clamp meter, but it is quite acceptable. And if we take into account the fact that when using digital clamp meter, you do not need to tear the conductor for measurement, then the result is excellent. Now I'm measuring the alternating current. To do this, press the cell button to switch the measurement mode to alternating current. I'm going to measure what current this transformer TSA76 consumes. Approximately 110 milliamps. 110 to 120. Now, using a conventional multimeter, I measure the current consumed. And the result, 119 milliamps. Almost the same result was shown by digital clamp meter. This suggests that they measure the current strength quite accurately. The next measurement mode is voltage. I'll take a couple of batteries to check. 1.6 volts. And this is 1.3 volts. In order to measure the AC voltage, you also need to press the cell button. And then the digital clamp meter switch to AC voltage measurement. 240 volts. The next mode is resistance measurement. I'll check a couple of resistances. This is a resistance at 680 ohms. And the device shows 678 ohms. And another resistance of 10 kiloohms. Exactly 10 kiloohms. That's right. The next mode is the measurement of an electrical circuit and an audible signal. Next, check the diodes. To check, I took the diode 5402. The device does not show anything in this direction, and in the opposite direction. 443. Great, the diode is working. The next mode is millivolt measurement. In some cases, this is a very useful feature. To test this mode, I found an almost completely discharged battery. Now let's see what this multimeter will show. 122 millivolts. The next mode is frequency measurement. For example, I will measure the frequency of the voltage in the electrical network. 49.9 Hz. In principle, this is the norm. The next mode of the multimeter is capacity measurement. I'll take a couple of capacitors. This is an electrolytic capacitor for 1 microfarad. And the multimeter shows 1.07 microfarad. And another 220 nanofarad capacitor. 243 nanofarads. The next mode is temperature measurement. In order to measure the temperature instead of probes, I will connect a thermocouple. Now the device shows 25.4 degrees. If you pinch the thermocouple with your fingers, the temperature rises. I also measure the temperature of the soldering iron tip. The soldering iron screen shows a temperature of 315 degrees. Let's check if this is really the case. The multimeter shows a maximum temperature of 255 degrees. Now I will check the temperature with another multimeter. This multimeter also shows a temperature of about 250 degrees, so the soldering iron needs calibration. And the last measurement mode is the NCV mode, that is, the search for an electric field. It is also often called the search mode for hidden electrical wires. It's an electrical wire. Well, the current clamp meter cope with this function perfectly. If you press the cell button in this mode, then the device switches to the phase wire search mode. We need a red wire. Here 0. This is a phase. As you can see, all modes in this multimeter, in these digital clamp meter work stably and without any problems. Also in this device there are several additional, very useful functions. For example, the max minutes button, that is, measuring the maximum and minimum values during measurement. In the current, voltage or resistance measurement mode, you can press the max minutes button and the device will remember the maximum and minimum peak values. For example, let's switch to voltage measurement mode. Now I will connect the multimeter to the power supply. And at the moment the voltage is 12.92 volts. Now press the max minutes button and the corresponding indicator lights up. And now I'm going to change the voltage up and down. It can be seen that the multimeter recorded a maximum value of 25.48 volts. If you press the max minutes button again, the device shows the minimum value that it has fixed, 4.11 volts. A very convenient and useful function in this multimeter. To reset the stored value, you need to press the button for a long time. And another very useful function in these current clamps is the measurement of the inrush current. To switch to this measurement mode, you need to switch to the current measurement mode and then press the inrush button. Now I will measure the starting current in this already familiar transformer. Now I'm applying voltage. The device recorded 3.16 amperes. I'll try again. 2.62 amps. As you can see, the starting current of this transformer is several times higher than its operating current, which was slightly more than 110 milliamps. This is a very useful function in this multimeter. In order to turn on the auto mode, you need to press this green button for a long time. And already being in this mode, the device automatically determines what it needs to measure: current strength, voltage, resistance, or just the ringing of an electrical circuit. Let's conduct a small experiment. Constant voltage, 1.6 volts. Resistance, almost 680 ohms. Voltage in the electrical network, 240 volts. The ringing of the electrical circuit, By the way, I would like to know the speed of this device. There are no delays, no hesitations, all measurements are made quickly and accurately. Also on the side wall there is another button. This is turning on the flashlight and stopping the readings on the screen. The voltage is 1.6 volts. When the button is pressed, the values on the screen are fixed. A long press of the button turns on the flashlight. Well, after testing, we can say with confidence that these digital clamp meter are a reliable and accurate measuring device that will be useful in any workshop. This concludes this video. If you liked it, then click the subscribe button so as not to miss a new video on my channel. I thank you for watching and see you soon.